Greetings, chemistry students. Today we're going to actually get into some more details with Unit 1 with atomic structure, learning about atoms. So, we're going to look today at our current model of the atom, the electron cloud model, which says that atoms are the smallest particle of an element that contains those physical properties of the element. And atoms have three particles called protons, neutrons, and electrons. I'm going to summarize and the central part of the atom is called the nucleus. I'm going to summarize these next three slides in a little chart that I'll show you in a minute. So, protons are positive in the nucleus. All atoms of the same element have the same number of protons, and one proton has a mass of one atomic mass unit. Neutrons are also in the nucleus, but they have no charge. The lack of charge is also why neutrons were the last particle to be discovered, is because they don't react to electromagnetic fields. A neutron also weighs one atomic mass unit. And then you have electrons. The mass of an electron is 0.0006 atomic mass units, which is really, really, really small. And so we just kind of round that down to zero. When we're counting up masses of the particles in an atom, we ignore the electrons because they're so insignificant compared to the rest of the atom as far as mass is concerned. They have a negative charge and they're found outside the nucleus in the electron cloud. So if we look at, we'll make a little chart where we have the particle, we have the mass, the charge, and the location. So the three particles, we have the proton, we have the neutron, and the electron. And protons have a mass of 1 AMU, neutrons are 1 AMU, and electrons are approximately 0 AMUs. The charge, protons are positive 1, neutrons are no charge, electrons are negative 1, and the location of protons is the nucleus, and then the electron cloud. So that's just a brief summary of all three of those previous slides. So we go back to the presentation. We have atomic number, which is symbolized with the letter Z because the German word for number is Zahlen, which starts with a Z. And a lot of early chemistry work was done in, German used to be the language of chemistry up until the 1930s and the rise of Hitler in Germany. And then after that, English has been the predominant language of chemistry. But atomic number, symbolized with the letter Z, is the number of protons. And this determines the identity of the element. And that's the number that's written on the periodic table up at the top of the little box. So, for instance, hydrogen, which has an atomic number of 1, has 1 proton. If you find an atom with only 1 proton in it, it is by definition a hydrogen atom. Oxygen has 8 protons. Any atom with 8 protons in it is an atom of oxygen, and so 8 is the atomic number of oxygen. Similarly with copper, it's number 29. It's also how we know we're not missing any elements in the periodic table. We've accounted for atoms that have between 1 and 118 protons. Could there be some undiscovered element with 119 protons? Absolutely. We haven't discovered that yet. Next, we have atomic mass or mass number. That is the sum of the protons and neutrons in the nucleus. So you count up protons plus neutrons, that's the atomic mass. And that number does not appear on the periodic table. I'll explain that other number on the periodic table next week. So there's a special notation that chemists use. They could just say 36Cl, where the 36 up here, where that is the mass. And they don't need to specify the atomic number because you can look on your periodic table and find that it's 17. Or sometimes they'll write the 17 down below it as a subscript. But 36 is the mass number or atomic mass. 17 is the atomic number. So that means that you have, if 17 is the atomic number, you have 17 protons. So if you take the total mass minus your 17 protons, you can find the number of neutrons. So 36 minus 17 gives you 19 neutrons. One other thing to point out, if you have 17 protons in the nucleus that are positively charged, they will attract 17 electrons into the electron cloud. So protons and electrons in a neutrally charged atom are equal, and then you have to be told the mass in order to figure out how many neutrons you have. All right. Now there's another way to write this. You could write it as Cl-36 to represent the atomic mass, or you could write it as chlorine-36. You may have seen, for instance, a reference to carbon 14. And carbon 14, that would have 6 protons, 6 electrons, and then 14 minus 6, or 8 neutrons. Carbon 14 is used in radiocarbon dating to figure out how old certain things are. There's also, if you're trying to make a nuclear weapon, there's uranium 235, where 235 is the mass. It's still got 92 protons, and then it's got 143 neutrons, because 235 minus 92. There's an assignment posted in Google Classroom for you to do now. It's this chart right here where I've given you some elements, and this is their mass numbers. So really, the first step you do is you take those numbers and you just copy them right down into the first thing, like 1 and 4 and 7. Let's skip down and let's do 64 for copper. The atomic number you need to look up on the periodic table. Hydrogen's number 1. Helium's number 2. Lithium's number 3. I did not just keep going in order all the way down. Copper, as we saw earlier, is number 29. For protons, the atomic number equals the number of protons. So that's going to be 1, 2, and 3. And then for copper, it's going to be 29. Same with electrons. It's going to be the same. Now for neutrons, you're going to have to do a little bit of subtraction. So you're going to take the mass number minus the atomic number to find the neutrons. So that would mean that this hydrogen has no neutrons. The helium has 2 neutrons, because 4 minus 2 is 2. For lithium, 7 minus 3, that would be 4 neutrons. And then for copper, 64 minus 29 is 35 neutrons. Feel free to use a calculator if you're uncertain about these calculations. All that being said, if you have any questions, feel free to reach out to me. Otherwise, y'all have a great day and a great week.